Solving equations involving absolute value, day 2. Start you off with a little review from yesterday, and then develop into a few more of the challenging problems that you might face regarding absolute value in equations. Example 1, much like yesterday, what you need to do is get rid of those absolute value signs. So you need to come up with two case equations, the positive and negative aspect of it. So I've read the absolute value sign, I rewrote the equation, n plus 7 equals 5. There's the positive aspect. The negative aspect, we have n plus 7 equals negative 5. Both equations, you need to get n alone. In order to do that, you'd subtract 7 from both sides of your equation here, leaving you with two possibilities, n equals negative 2 and n equals negative 12. These would be the two possibilities for equation or example 1, so negative 2 and negative 12. Next, you'd go ahead and graph this solution set on a graph. We have our generic little number line here. Graph these two plots. This is where negative 2 falls and negative 12 falls. So there's our two possibilities graphed. Example 2, a little bit different here. We have actually a couple of two-step process. Still need to break it down into two equations or two cases here. So positive, negative here. Get rid of the absolute value. So we have 3z minus 3 equals 9. Now we need the negative piece. That being 3z minus 3 equals negative 9. Still need to get z alone in each of the equations. So I'll add 3 to both sides on each of the equations. We have 3z equals negative 6. And we have 3z equals 12. Z is not alone, so divide both sides by 3. And we have z equals 4 as a possibility. Divide both sides by 3 here. And we have z equals negative 2. So our options here being 4 and negative 2. Again, you'll need to graph on a number line. Generic graph, plot my points. Here's where negative 2 would fall. Here's where 4 would fall. The next part, I just want you to go ahead and check it. Well, how do you check it? Well, you take your two possibilities, 4 and negative 2, put it back into your equation up here. So if I put in 4, I have 3z times 4 is going to give you 12. 12 minus 3 is 9. The absolute value of 9 is 9. Second scenario, well, plug negative 2 in. If I put in negative 2, we have 3 times negative 2 is negative 6. Negative 6 minus 3 is negative 9. The absolute value of negative 9 is 9, so it would check out. That's how you check your answers. Next couple examples, a little new look here in comparison to the first two of what you had yesterday. What you need to do is isolate the absolute value. So you need to get the absolute value by itself. On the left side, you have negative 2. Well, negative 2 is next to that set or that absolute value. What's happening there is multiplication. So in order to get rid of multiplication, you're going to divide. Divide by negative 2 on both sides. When you do that, those negative 2's would cancel out. You would have the absolute value 4t minus 8 equals 20 divided by negative 2 is going to give you negative 10. As discussed yesterday, this possibility here is no solution. Why is it no solution? Well, you cannot have the absolute value of something equaling a negative outcome. This cannot happen. So, no solution. Just looking at example 3, it looks like it's going to have a solution because it's a positive 20. But after you get rid of that negative 2 there and you isolate your absolute value, you find out that this has no solution because absolute value cannot equal a negative outcome. Example 4, notice here we need to get rid of the 2 that is multiplying and the minus 12. Well, you follow your same steps as you would solving equations. When you solve equations, you get rid of that addition and subtraction first. So I need to get rid of the positive 12. So I'm going to add 12 to both sides. And if you look at this problem, this has a negative 8. Well, if you look at that, you're like, oh, this should have no solution. Well, As you work through this problem and you isolate your absolute value, you'll determine it actually does have solutions. So I'm going to work this out. We'll drop down the 2 and the absolute value x minus 7. The 12s cancel out. You have negative 8 plus 12 is a positive 4. Next step, go ahead and get rid of the 2. So I'm going to divide both sides by 2. We have the absolute value now isolated, and we have 4 divided by 2 gives us 2. So you notice that the absolute value of x minus 7 is 2, which is a positive outcome. That does work. So the next step is to go ahead and get rid of the absolute value. Your two cases, well, x minus 7 equals 2, and you have x minus 7 equals negative 2. Now you're at the same step that you worked through yesterday. So we'd go ahead, add 7 to both sides in both equations, and we get x by itself. We find out x is 9, and we find out x is 5. Here's our two scenarios, 9 and 5. And again, if you wanted to double check, you can set that back into the original equation. Last stretch here, why don't you go ahead and try to work through example 5. Example 5 is pretty similar to the example that we just accomplished. So why don't you go ahead, if you need to, refer back to example 4 to work through example 5. So go ahead, pause the video, and start working through this. Remember, you need to get the absolute value isolated. So you need to get rid of the 3 and the negative 10. Make sure you take the appropriate step first, otherwise that answer would be incorrect. First step for isolation, add 10 to both sides. Here's what the equation would now look like working down the paper. Second step, divide each side by 3, because you need to get rid of the 3, which is multiplying into the absolute value. New equation now, we have absolute value r minus 3 equals 7. Second thing, go ahead and split this into the two cases. Now that you have the absolute value isolated, solve for r in each of the cases by adding 3. And you'd find out that r equals 10 and r equals negative 4. So the two possibilities here are 10 and negative 4. Check out example 6. Go ahead, pause the video, work through it, and check back in. Now that you're back here, you'd notice that the absolute value here is already isolated. So you actually could break it down into two cases. Well, looking at this problem, you really don't even need to break it down into two cases. Why? Well, it's telling us that the absolute value of 6y minus 7 is equal to negative 1. And we know that the absolute value of something cannot equate to that negative number. So this here would be no solution again. This will conclude absolute value equations day 2.